Hello calculus students, welcome to one more example here in our lesson on related rates. And in this video we're just going to solve this particular problem with two trains moving at 90-degree angles to each other. So the situation is kind of like this. You got one train going this way, you got another train coming along this way at 90-degree angles to each other. Okay, and one train, this distance here is we'll call this X, and this distance here we'll call it Y, and this point here, that's the station. Okay. And then the distance from the trains to each other is basically this point right here, these 2 points. This is the distance between the two trains. Now, as these 2 points move closer to each other, this blue line is also changing, right? So as these 2 dots move closer and closer, you can imagine that this blue line is also shrinking. And we want to know at what rate is the distance between the trains decreasing given this information. Okay? So we can look at it this way. X squared plus y squared is equal to d squared. This is just the Pythagorean theorem. And now then we can take the derivative with respect to time. All of these problems right now have the derivative changing, or the functions changing with respect to time. So then this becomes 2x dx dt plus 2y dy dt equals 2d. Oh, I realize I don't want to use d because I'm going to end up with dd. So let's call this w. Okay, so w. So this is going to be 2w dw dt. And this is what we're looking for. We want to know what is dw dt when certain other scenarios are given here. So one thing we can do is cancel all the 2's. We could factor that out and divide them out. And now we can use the information in the problem to help us solve. So at this point X, this train here is coming in at, it's 225 miles away, okay, and it's moving this distance here at 45 miles per hour. Then this distance here, it's moving in this direction toward us at the same distance here. This is going in at, let's see, 60 miles per hour. No, the distance, rather, is 300 miles. That's Y. And it's changing at a rate of 60 miles per hour. And this is equal to W, whatever that is, times dw dt. Okay, so let's use the information in the problem now to solve for w. Well, this is not too difficult. If this is 225 and this is 300, then w, which is the distance, well, w is just equal to the square root of 225 squared plus 300 squared. Okay. So that means our final answer is 225 times 45 plus 300 times 60, all divided by the square root here. But one more thing that we really have to be aware of is the fact that these distances here are decreasing. All right, these distances are decreasing, just like w. The size of w is decreasing. So from this point of reference, these rates are negative, okay, because they're going toward something. So if you have an object moving toward you, the velocity of that object with respect to you is negative. Okay. So this is 225 times negative 45 plus 300 times negative 60 over this crazy looking square root here. 225 squared plus 300 squared is equal to dw over dt. Okay. And then we'll just, I'll leave this here so you can see the exact answer. But, of course, there's a simpler answer. You can just plug this through a calculator and get a numerical value for it. And this turns out to be negative 72. And the units here are miles per hour. So this distance here is shrinking at a rate of 72 miles per hour. At that very instant. If these numbers were different, at the moment that the trains go a little bit closer, then this distance actually, the rate at which this blue line is shrinking also changes as well. So there you have it, some nice examples of related rates. Okay, and if you look back at this example and notice here we have 3 variables, and we kept those 3 variables. We didn't try to change them into something else. That's because we didn't really have to. In the previous example, the previous video, we're talking about the upside down cone. We had to change one variable to another. Well, we didn't have to, but it made a lot more sense to do that because we weren't given as much information as we would have liked. Okay. So there is one more problem on this worksheet, and I'd like all of you to do this on your own so you can figure this out on your own. Come to class ready to do this one and share and explain your answers. Thank you for watching and have a wonderful day.